tetrahedral concept of carbon. As we know, atomic number of carbon is 6. So its electronic configuration will be 1s2, 2s2, 2p2. This is the ground state. In excited state, one of the electron jump to the higher level, so the electronic configuration becomes 1s2, 2s1 and 2p3. So we can show it like this with the p orbitals. This is the s and p with the 1 electron in s and the 3 electrons in p. So overall hybridization of carbon is sp3. With sp3 as hybridization, carbon makes 4 bonds. One is like this, one is here, one is here, and the last one, which is above the line, is here. The bond angle is approximately around 105 degree. The bond shown with a dashed line is below the plane. The one shown with the bold line is above the plane, and other two they are in plane. So a carbon with 4 different groups and bond angle of approximately 109.5 degree is a tetrahedral carbon. The carbon atom uses its sp3 orbitals to achieve this geometry. So when all the 4 groups or attachments are different, then the carbon is a stereo center. The overall structure is tetrahedron, that is a pyramid with all faces being equilateral triangles, or nearly so. We can draw it like this: a carbon or we can show it like this: it looks like a tetrahedron. When all the four groups are different, it will be like this, and that particular carbon will be the stereo center. Now the bond angles will be quite different, like it will be 109.5 degree. The angle between the fluorine, hydrogen and carbon, it will be 110.1 degree, and the angle between chlorine and bromine, it will be like 111.6 degree. So we can see, as there are four groups attached, the steric number will be equal to 4. Also, the coordination number will also be equal to 4. The common examples of tetrahedral carbon include like CH4, PO4 3 negative, SO4 2 negative. All these are examples of the tetrahedral carbon. All these have bond pairs like this. As well as there are few examples in which we have both bond pair as well as lone pair, and geometry is still tetrahedral. Let's have a look at the example. It's ammonia with nitrogen and the 3 hydrogen, water H2O. We can see, let's see the example of NH3. Here is the nitrogen. It is having 3 bonds and it is having a lone pair. As we know, atomic number of nitrogen is 5. Sorry, it's 7. So we can write it like this: 2 and 5, with the 2 electrons in the K shell and the 5 electrons in the L shell. Or we can also write it like 1s2, 2s2 and 2p3. So it is having a lone pair and the 3 bond pairs with the hybridization, that is sp3, or we can say geometry is sp3. There is a formula to calculate the hybridization. Let's have a look on that. Hybridization is equal to central atom, number of electrons of central atom, number of valence electron of central atom plus number of monovalent atom minus the charge of cation plus the charge of anion overall divided by 2. Let's understand it with the help of example like NH3. Valence electron of nitrogen is 5, number of monovalent atom is 3, that is hydrogen is 3, there is no cation plus there is no anion. Overall divided by 2, this is equal to 8 upon 2 equal to 4. 4 means we are having 1 S and we are having 3 P, that is the hybridization is sp3 with the 1 as a lone pair and 3 as a bond pair. Similarly, we can see with the example of water, oxygen with atomic number 8 with the 2 electrons in the first shell, that is K, and the 6 electrons in the second shell, which is L. So 6 plus 2 minus 0 plus 0 divided by 2, this is equal to 8 upon 2 is equal to 4. So again we get the hybridization sp3. Now we are having oxygen here with the 2 hydrogen, so it means we are having 2 bond pair and we are having 2 lone pair. So these are the examples with the lone pair as well as bond pair, and the bond angle keeps on differing depending upon the interaction between the lone pair and the bond pair. It is approximately around 110 degree. So we can name this structure as a bent structure or V-shaped. So this is all about the tetrahedral concept of the carbon, which include the other examples also like ammonia and the water with the lone pair and the bond pair, and the one we have seen, its shape will be pyramidal ammonia, and we have seen the different examples of the tetrahedral carbon. So overall we can say that carbon with the 4 bonds is a tetrahedral carbon and the bond angle will be 109.5 degree. Thank you.